Continuing with my learning in pivoting and buffer overflow, this time I create a lab using the DriftingBlues 9 machine from HackMyVM and Fawkes from VulnHub. The lab is straightforward. I simply set up the two machines to communicate with each other, and my machine can only communicate with DriftingBlues 9. Therefore, to gain access to the Fawkes machine, I first need to exploit DriftingBlues 9. From there, I can use Chisel and Socket to pivot and gain access to the Fawkes. As always, I start by enumerating ports and service using Nmap with the following options: P to scan all ports, Open to display only open ports, excluding closed filters 1, min rate 5000 to send at least 5000 packets per second to the target, N to disable reverse DNS lookup, PN to assume the host is alive, SS for a scene scan, a stealth technique that doesn't complete TCP connection, V for verbose output. For service and version recognition, I use the following options: SC to activate the option to run default scripts to detect vulnerabilities and gather additional information during the scan, SV to enable the detection of service version on open ports, allowing me to identify application and their version for security evaluation. Nmap found 3 ports, and I noticed that port 80 uses AP-PHP microblock, so I searched for an exploit to exploit the microblock. The exploit worked perfectly, and even revealed some credentials. Since the SSH service is not active, I gained access with a reverse shell. Inside the system, I discovered the user Clapton, for whom I already have the credentials, and I log in with this user. I found a note indicating the next step, exploiting a buffer overflow in the binary input. I downloaded it to my machine to perform local tests. To exploit this buffer overflow, I execute the program input using GDB in quiet mode. In GDB, generate a unique pattern to find the offset needed to override the EIP register. Next, I needed to craft a payload to exploit the buffer overflow. and gain control of the EIP. I decided to use a knob sleeve followed by the shellcode to achieve this. But before, we need to calculate the correct offset. The shellcode we are using has a size of 33 bytes, and we want to place it after 171 bytes of padding. So to calculate the offset, we subtract the size of the shellcode from the desired padding size. The offset value, which is 138 bytes, represents the number of padding bytes we need to insert before the shellcode to reach the EIP register. Now that the payload is ready, I aim to redirect the EIP register to the address where my knob sleeve and shellcode reside. After successfully exploiting the buffer overflow locally, I want to ensure the same exploit would work on the target machine and get me a root shell. After successfully exploiting this machine, I execute the command hostname I to identify the machine's IP address and discover another active network interface. I then use a small script to find out which hosts were active on the machine. The script found an active host, which should be the machine name Fawkes, so I performed a quick port scan. Three ports were possible active, so I used the tool Shell to establish communication from my machine through the DriftingBlues 9 machine to the Fawkes machine. On my machine, I act as a server on port 1234, while on the DriftingBlues 9 machine, I act as a client and connect to my IP on port 1234, using SOCKS as remote port forwarding. To make SOCKS work correctly, I had to edit the proxychains.conf file and create a SOCKS file connection on localhost port 1080, where the connection made by Chisel Listen. With the help of proxychains, I was able to connect to the Fawkes machine and attempt to exploit it. I performed a port scan using Nmap with the following options. ST, only normal TCP connection will be possible with the proxy to specify a TCP scan. PN, assume the host is alive. You can use your preferred additional parameters. Nmap found several open ports, including port 21 with the FTP service open. I connected as anonymous and found a binary that I downloaded. running the binary, it requests an input, and I discovered a buffer overflow vulnerability when providing excess data, causing a segmentation fault error due to memory allocation issues. Just like with the first machine, I used the tool GDB to try to exploit the buffer overflow. To exploit this buffer overflow, I execute the program using GDB. In GDB, generate a unique pattern to find the offset needed to overwrite the EIP register. Next, I needed the GMP ESP instruction, which I can obtain using the Object Dump tool. After that, I used MSFVenom to create the shell code. Finally, all that was left was to create the script with all the gathered information. The script worked, and I obtained a reverse shell by exploiting the buffer overflow locally, and now I need to replicate this on the victim's machine. However, remember that I don't have a direct connection to this machine, so the reverse shell must pass through the DriftingBlues 9 machine to reach mine. For this, I used the socket tool. I needed to recreate the shellcode with MSFVenom, but this time pointing it to the DriftingBlues 9 machine. Then on the DriftingBlues 9 machine, I set up socket to redirect everything received on port 4444 to my machine on port 443. With everything configured, I only needed to execute the script using proxy change. This way I gained access to the machine, but I found myself inside a container. I tried the command sudo l, and the user I gained access with can execute any command without providing a password. So I ran the command sudo bin sh and gained root access to the container. Inside the container, I found a node instructing me to analyze the traffic passing through the FTP service and find a user. I used tcpdump for this. With the help of tcpdump, I obtained some credentials, which allow me to log in via SSH and escape the container. To escalate privilege, I checked the version of sudo and it was vulnerable. So I searched for an exploit to leverage this vulnerability and gain root access, successfully completing the Fawkes machine. Using the techniques of pivoting and buffer overflow, I managed to solve these two machines, though there is still much to learn and improve. I hope you can see the progress I'm making through these videos. Remember to like, subscribe, and leave a comment. Until next time.